Conservation laws are fundamental principles in physics that dictate that certain physical quantities do not change in a closed system, despite the interactions within it. One of the most recognized laws is the conservation of energy, which states that the total energy in an isolated system remains constant, even though it can be transformed from one form to another. In fact, this law extends beyond classical mechanics and also includes thermal, electrical, and other types of energy. Furthermore, the principle of conservation of energy is key to understanding phenomena ranging from subatomic interactions to the behavior of celestial bodies, such as stars or galaxies. Another fundamental principle is the conservation of linear momentum, which states that the quantity of motion of a closed system is conserved before, during, and after internal interactions. This is observed in phenomena such as collisions, where momentum does not change unless an external force acts on the system. In this sense, a distinction can be made between elastic collisions, where there is no loss of kinetic energy, and inelastic collisions, where some of the energy is converted into other forms, such as heat or deformation. Through simple examples and mathematical models such as the parallelogram rule for analyzing motion in various directions, it is demonstrated how these laws apply to everyday situations such as collisions between vehicles or interactions at the molecular level.